Okay, so my name is Alex Matronic. I am a data analyst in driver experience, so product department, right? And I like, I like to nail down the things to the really bottom, and one of my interests is this SQL. And so I found very interesting and challenging book, SQL and relational theory. You see, is kind of, and I would say I got from it just about 20% of knowledge, and I hope to deliver 20% of what, or 20% what I got from this book. And yesterday I talked with my friend and told him, I'm going to talk on a data summit about a relational model. And he told me, so it's the very basics, right? And it was so frustrating for me. So I hope that I will deliver something useful. Okay, so let's jump. Let's start from some very, very basic thing, a piece of history about the relational model and the SQL. So the relational model, as you see, was proposed in 1969 by an English man, and it was proposed as a huge mathematical thing. And eventually, let me show this guy. Here it is. He is, Mr. Code. And his idea for proposing a relational model was that in the times, in 60s, computer programmers, they have to deal with data in a very complicated ways, and you had to deal with data like you should know how a computer works, and you have to keep in your mind too many ideas. And so his idea was to separate data model from computer. And so he proposed this model. And there were on the stage at that moment, there was different models as well. For example, actually we know about them. Now, any guesses? What models were besides relational model in 60s? Non-relational. Yes, you're right. Candy for you, yeah. Any more detailed? Flat? Yeah, okay, maybe, yeah, okay, get the candy, yeah. So the idea was, there was, you see, I'm not, sorry, Mark. Later. So there were, for example, hierarchical database and network database. And I believe we currently have these databases as well. Okay, but relational model won. And here is the guy, his surname is Date, and he basically wrote this book, what I showed to you. And this is just, I let you a couple of seconds to read this thing, that surprisingly, relational model is not a SQL, or SQL is not a relational model. Can you, yeah, you're right. I mean, SQL is not relational. Okay, you can. It's not relational in meaning that it's not. It violates relational model principles. And it sounds crazy, right? Because the guy who developed relational model, he also participated in the development of SQL standard. So how it could happen? And the thing is that at that moment, IBM was a very powerful company, and the managers in this company, they decided that SQL is a very good thing for market, and they pushed this SQL standard, and it became the hero of the market. I think we can say similar about Java and Sun Microsystems, more or less. Okay, let's jump to more details. So the idea, we have the relational model. Kind of on top of it, we have SQL standard, and on top of SQL standard, we have different implementations of databases, right? What do you think? What is the most SQL compliant database? MySQL. Okay. Actually, I didn't check with MS SQL, but Postgres seems to be very good. They kind of 97 or 98% of the standard they implemented. Okay, we come back in some slides to MySQL and about my frustration with this database. And now let's jump to some practical things. And actually, if you have come on, okay, do you see? More or less. One of the things in the proper relational model is that column names between tables should match. Just let me give an example. For example, we have a table city, admin system city. I believe everyone knows this table, right? And for city, we have ID column, but in other tables, it's not and it's called ID, but in all other tables, it's called city ID. And so every time when we join these tables, we have to manually write that I want to join ID on city ID. And this is kind of okayish, but I believe in a more human-friendly way we could avoid this. And here is a small trick. If you're working with constantly with the same set of tables, actually you can define this is from our Redshift, and you can try it right now in your SQL client, database client. Here I am defining a temporary view, what's called city, and extract the columns what I want from there, right? And what does it help us or not? Yeah, and as you see, I just want to make a hint to our data engineers. I discovered that we can create not only temporary views in our database, but just views without temporary. So I can create maybe. Yeah. So everyone now, while Evgeny not. Okay. It's a secret. Okay. Okay, and here let me show what happens if this, when we have proper column names in both sides. You see that in the natural using natural join, I don't need to specify on using. I just define what columns what tables I want to join, and I get a table. Oops, you have not seen numbers. I forgot. Next slide is a bit of kind of quiz. Guess how many writes we had in Hapsalu yesterday? 1,000? Huh? 6.5? I think 6.5 was the closest. Max, that was you. Okay, yeah, take your candy. So this is the distribution. Yeah, actually, I had to find a suitable day because on some days there was kind of nothing. Yeah, and here, please pay attention. I again use here natural join, and I don't define columns what I'm joining. Yeah, next thing with the relational model is nulls. In kind of every time we meet nulls in our database, right? And kind of it's so organic for us. But the thing is that relational model doesn't permit nulls. How it can be? The thing, again, is that relational model is based on theory of sets, and theory of sets doesn't have this idea of null. So if you have in your tuple, in your row, a null, it means it's not a tuple, and it means it's not a relational model. And it means that we can't apply to our queries logical statements and predicates properly. Yeah, here I show you an example that nulls in, this is from our Redshift, nulls has different meanings in different situations. Because as you see, if we take sum of values from an empty set, we get null. But actually, what is the sum of an empty set? 0. It should be 0, actually, right? So in some situations, null means 0. In other situations, when we take average of empty set, it's kind of not defined, right? So we can't calculate average because we divide by 0, right? We can't. So in this case, null means not defined. In other situations, we have, you see, third variant that if we make a left join, null means no corresponding row. And actually, as I told you before, that we are, for example, as data scientists, data analysts and scientists, thanks to permissions from our data engineers, we can create temporary tables and temporary views. Recently, Francesco shared his experience on using temporary tables and how it's convenient and increase the speed of some stuff. So here, if you create in a table, a temporary table, you can also use constraints to say that I don't want to have nulls in my column. Yep. And unfortunately, this is I think one of the fewest kind of constraints that Redshift supports. For example, Redshift doesn't support uniqueness. Even if you define in Redshift that, hey, I want ID to be unique, Redshift will answer that, okay, kind of I will take it for informational purposes, but not kind of I will not imply this constraint. And this is a trade-off between, as we discussed it with Lukasz, I asked him, hey, Lukasz, why Redshift doesn't provide this constraint properly? And he told me it's very expensive. Right, Lukasz? You hear, no? Okay, no Lukasz, no confirmation. Yeah, so just believe me. Yeah, and you know that actually in SQL we use 3-valued logic, and this is and we even have unknown word, and this is very interesting. I just can briefly show you the table in Redshift. Yep. So we have actually many multiple unknowns as well. Take this into your. And here, yeah, back to Mark's comment about MySQL. Recently, I was talking with our engineers from Fleet team, and I asked my Marty, why are you using not booleans, but tiny integer type instead of proper Boolean. And he told me it's a MySQL feature that you can't use. There are no Boolean type. You can kind of 1 means true, 0 means false. And I'm really frustrated when I have to write like the second line, where is finished is true. It's kind of not human. And the thing, and I kind of, so how happy am I that I'm using Redshift, because Redshift supports proper logical thing, where is finished, and that's all. I don't need to write is finished, where true is true. It's kind of sounds, yeah, stupid. But what was my frustration when I found, and when preparing to this presentation, you see I found this comment in Redshift help that please use still true is true, because opposite to this, you can get some unexpected results. But the problem is, you know why? Because Redshift supports nulls, and because of nulls, we have this problem. Okay, let's jump through duplicates. Just a short mention that relational theory also doesn't like duplicates, because okay. Now a bit more deep topic. When we have properly defined tables, it means we have proper set theory in place, and it means we can use some logic rules to optimize or modify our queries. And now just a short lesson in logic. So let's assume we have a query like this. I mean, not query, but question. Get manufacturers of cars that were used in orders last week. Those manufacturers different from that of every car in London. To translate it to more human, I took it from the book and translated to our context to cars. But actually the idea is, what was the brands of cars that were not used in London, but were used in some other countries? I know that we can build this query some other ways, but now just let's check how logic rules can be applied to this. So here I show you kind of pseudocode about this query. And here we apply the quantification law, as you see. So we take, on the top you see original query, and on the bottom we apply some rule and get some modification. I believe only few of us can follow this jump from this to there, so I'm not stopping here too much. So we have one step of conversion, then we have next step of conversion then we get one more conversion and one more conversion. And now finally we kind of get our final query, and this query can be translated into SQL. Actually, okay, it's too small. The thing is, guess what brands of cars are not used by in London but used elsewhere? Lada. Yeah, you're right. I run this query and it returns kind of about 100 rows, so it's boring. And I decided that let's limit it, and I checked what cars are used in Narva but not used in London. In London, Narva is a small city, kind of close to Russia, here in Estonia. Okay, so and when we check, let me. So there was just here, yeah, right. It's kind of unexpected for me, Opel and Chrysler. Yes, that's totally possible. Yeah, actually, I didn't look. Yeah, thanks. I surprised that we don't see here ladder, but that's maybe no ladder in Narva. Mark, you had some question? Okay. Yeah. So just to resume my this exercise with logic, the idea is that when we have properly set up tables, we can apply logic rules, and it it allow us to build more sophisticated to answer to more sophisticated questions. Yeah, that was my proposal. And here one more query. I found two. For example, this query shows drivers who yesterday worked in Tallinn, but today they work in Tartu. Yep, so if you want later, you can check in more detail how it works. Or just two drivers there. Here, oops, wait, not this one. This query, yep. Okay, let's go further. Okay, we're skipping this stuff, optimization queries, and this is how it was optimized. Doesn't matter. Yeah, I just, one thing not supported by Redshift yet. They say explicitly, we don't support yet this query. And one more announcement from Redshift. This spring, they introduced recursive queries. Anyone needs to produce recursive queries? No? How? Yeah, so recursive query is like, here I'm showing an example. When we, for example, we have in our database, we have drivers, and then we create a new driver, and this new driver is created from previous driver, right? And so initially we can collect more and more drivers, and to get, for example, if you analyze in churn of drivers, you would like to get the whole history of all these guys and girls, and not to introduce noise by different driver accounts. And here, so now Redshift allow us to build these recursive queries. And here I show a driver with the greatest amount of driver accounts. And you see it's 33 accounts for one driver. I didn't check his or her details. Yeah, but now you know. Okay, we have. So, and just to sum up, what can we do when if we want to have comfortable SQL code, right? I'm leaving it for a couple of seconds. And so, yeah, thank you very much. You give me an opportunity to learn relational theory, actually. Thank you.